Hello, everyone. Welcome back to Taiji. I don't really remember what the heck I was doing. I know. So this is like my second session. Everything else I did in the first session, and now like I know I left a bunch of what's in here. Have I been here? Huh. I guess yeah, that went up here. So did I do this already? I must have, right? Yeah. I did a bunch of stuff in the first session, and I left, like, some of like, lasers. Like, there were a number of puzzles, I recall, where oh, you can just click this, interesting. Where, like, I got through the area that taught you how to use some mechanic. And then the very last puzzle on it was just too hard. And I didn't know how to do it. For example, so have I been in here, by the way? Is this a thing? Does this exist? Yeah, this is just a bridge. Okay, it looks kind of like it would be a temple to go somewhere. So I don't know what to do about these puzzles at all. But now, so remember, this was the very first place we went. And there's like a 4x6 at the end that's supposed to be solved somehow. And I couldn't find any evidence of like what is the opposite of it supposed to be. Is this staircase like the bookend of it? Because let me go look up how. Look at this. There's this. These bits are sticking in for some reason. This has to mean something. This isn't just aesthetic. Right? But how do you correlate this staircase with what's at the exit? What's at the end goal, right? Because this, you could imagine this being like a 3x1 section or something, right? This is off on the left and right. This is on the left and right. This is off on the left and right, right? And then we go up here, and it's the opposite of that. So that's interesting. These two appear to be opposites of each other. And this is a 4x1. I presume there's an opposite of it somewhere? Off, on, from the bottom. There's also the shape of this whole region we're walking through. Notice here, it's like wide, wide, narrow, wide, for example. Here it's kind of broken. I don't know what to make of that. But I don't know what to do with that information. There's not like any one thing which is clearly the opposite of the thing up there. I would be looking for the whole point of going up there was to see what its dimensions were. It was 4 by something, and I've forgotten what the something was. 4 by 5 tall. And it's got like what looks like markings on the outside. So I have this 2x5 area that I don't understand what to do with, sort of, right? And it's in the middle of the picture. So is there some place that I can find a 2x5 shape? Or 2 1x5 shapes, maybe? What about this area? There's a narrow and a wide. And then looks like another wide here. This is a wide, and This is also a wide, and this is also a wide. Like, I don't think it's telling me that much. Now here's this narrow part. And then mostly wides and a narrow, like, I don't know. This staircase that we were considering is a 4x1, so that doesn't seem to help. The river to the side, is this communicating anything to me? You can't even really walk over there and look at it, so I don't think it can be. I'm not allowed to even go up here for some reason. Still, I mean, like, I guess these things are sticking out, but it doesn't look like they're sticking out so much that I couldn't walk by them at this spot. I can't really make sense of it. Well, there's two 1x5s right over there, I guess. Surely not. That would be... There's no reason to connect these two that I can see. And when you step on this, it's actually a 3x5 puzzle you're supposed to do. Based, I think, on these guys. And not on anything else. I never did figure that one out either, of course, as you can see. Did I do this whole area? I think I got stuck on the final puzzle as well. Here. So that one's done. This one appears to look like that, but then what goes in the middle? I still don't understand why this one is right. Remember, on this we just like tested all 8 possibilities for the hidden squares. I wonder, are there let's go find some other ones that had this kind of... So there were some down here, weren't there, that had some like missing bits that you had to like fill in by understanding them. This is done, right? Yeah. Like these, right? I had a theory when I was looking at the ones we just were standing by that maybe like the leftmost column was establishing the defaults for the column, and then for the row, and then after that, but and anything that wasn't specified was not the default. But this is a clear counterexample to that. Because here, like, this could be, it seems, establishing that, you know, this column, this row doesn't have a default. That just doesn't make any sense, right? These spaces are both empty, and yet one of them's on and the other's off. So there's something about this column that is somehow saying, okay, you have to put these in white because we didn't write them in black. And like likewise, this column appears to be saying the same thing about whites. Here, this cell in the middle is really puzzling. It doesn't seem to be any kind of columnar influence, because this column has 2 absent cells, one of which is supposed to be empty and the other is supposed to be filled. And the same is true in this row. This row has 2 absent cells, but one is supposed to be empty and one's supposed to be filled. So there isn't some kind of like dominating row or column. But we've seen other puzzles where it seems a lot like this one, right? It seems to be saying, like, the right half of the grid is, like, the whites have to be communicated explicitly and the darks have to be communicated implicitly, or are communicated implicitly by not being there. Now on this side, it's the opposite. The blacks are communicated explicitly, and the whites are communicated by their absence. And that seems to make sense here as well. So, like, that was the idea that I had. But in this, I can't see any, like, guiding principle like that, right? I'm wondering if there's something about, like, adjacent neighbor count or something. Like, the ones that are filled in explicitly with blocks, you obviously do the way they're filled in. These spaces are next to whites but not next to darks, so we mark them as dark. These spaces are next to darks but not whites. That all fits for here and this one as well. But it leaves us with ambiguity here because this space is not next to light or dark, right? Oh, sorry, it's next to an equal number of light and dark, and yet we're supposed to leave it dark. Still, that's the only ambiguity that that rule leaves us compared to earlier when we were like, well, kind of the right looks darkish and the left looks lightish, doesn't it? So maybe that concept applies over here as well, and we just know that if there's a conflict, we leave it dark? I don't think that's right, but let's at least try it. What's in here, by the way? Shouldn't this be open? I have a thing going to it, don't I? Weird. So let's look at this one. Yeah, see, that rule doesn't really fit, because here, like for these two, yes, it's fine. But here, we have a dark and a light next to this vacant space, and it's supposed to be on instead of being off, like it was in the other area where there was something adjacent to an equal number. We could try, like, okay, say that one has to be on, because it's next to two offs. And there are still 4 ambiguous spots, right? Well, only sort of. In another sense, there's only 2. Wait, 1... There's only 3, actually. And I think we can reasonably say this one should be the same as that one, because they're both, like, black on the left and white on the right. So we could try the possibilities of what light black, light dark, and dark white should mean. And I guess over here we have something that says dark light seems to be a plus, like on. So that would be on, and that would be on, and this I guess would be off. Yeah, but none of those possibilities work. So it would seem then that this fifth row and the second row are actually supposed to be different from each other for a reason I don't understand. So let's test the possibilities with that then. Let's say that this one's on, therefore this is off. And let's turn that one on. See, this is right. Why? This makes no sense. I just haven't figured out what I'm supposed to... Is there like... Oh, I was looking at the first video I did. And I remembered this concept of like other nearby geography hinting the answers to you. But I don't see anything here that looks at all like this shape, do I? Maybe there's something up here that I forgot about? It doesn't look like it. Nothing over here. Are these staircases special somehow? They don't look like it. It's really hard to map these diagonal lines to ons and offs on this anyway, right? Although... yeah, it's really not easy to see whether these are connected at all. You can sort of imagine 1, 2, 3, 4, 5 heights, right? There's kind of a 6th height down here, but it's clearly offset from the rest. And then on the right, we'd have like off, on, off, on. Which is not at all what we see here. So I don't think the staircase is related. I don't know why I got the answer to that. It doesn't make any sense. Well, it looks like I can come out through here, doesn't it? Like something's going to open a shortcut that lets me go from here to down there. Oh. I never did this one. This was... okay, this isn't like a final exam puzzle exactly, but it's a shortcut puzzle. Okay, remind me how these work. Yeah, there has to be in each connected region exactly 2 of each color that's present in a region must be present with size exactly 2. So this already is quite a lot of information, isn't it? We know we have to have a connected path from here to here that goes through this point and doesn't touch a single other black space. So it must go like this. And I guess we're somehow cutting off all the other pairs of blacks from each other. And some of them we can also mark as white if we want. Not this one. But notice, if this comes down here, it looks like it's going to touch both of these, which is bad. So we want to put a block in here, but that's also bad, right? Now it's only touching one. The answer is it touches one of them, and the other one we can mark black because it's not part of our overall path to get here. Now, it looks like I could have this square on or off at my leisure, and likewise these squares, but I guess I'll just leave them off. These guys have to talk to each other and don't want to talk to anyone else, so I'll put a marker there. This has to come out. That's pretty interesting. This black needs to get to a friend, doesn't it? So we have to go around that. And connect up here. But this is impossible, what I've just written down. This can't be the answer, can it? Because now we have a purple that never gets to connect to anyone. Okay, show me. Let me just make sure I don't have any weird false assumptions here. We know we have to cross the bridge, so we need those lit up, and the things adjacent to them lit up. We can't touch any more... These regions will, at the end, be connected. So we can't touch any more blacks, or they would be unhappy. This must be lit up because it's got to be part of this region somehow. But doesn't that immediately create a problem for this? I mean... Right? It has to get out this way. We have to go here. It has to get out this way. It has to come up. We have to go up. We have to go right. It has to go right. We don't have to continue straight here. We could go this way. But aren't there still going to be problems when we have to get back down here to connect to this somehow, right? This now has to get out. I guess this has to go up then. Hang on. Yeah, this is part of the same region as this, so it can't touch black cubes either. I see. So maybe we can get this black to connect to that one. Maybe that's what's going on. That's why we're doing this. Okay, I see. And then it can grab this purple as well. Very cute. Ah, no, there is a reason that I... Well... Does it matter whether I go up here or down here? It seems more... No, I can't go... Right. I can't go up to any of these squares because then I would be making these blacks disconnected from each other, which they don't want. So these all have to be off, which means there's a line between them. Lines here seem fine. These have to, not that one, have to be off. So this has to be on, because if it were off, there would be a problem with this square. Wow, is that true? Yeah, because this square has to be off because it's next to our big old thing. And so if this were off, they would all join up, so it's not. So it goes like that. There we go, that looks right. Okay, cool. So now I can use that shortcut, except I don't really have any internalized idea of what the map looks like, and so I don't know where to go ever. Ooh, yeah, look at that. These are these are lit up now. This one I don't think was lit up when I came up here the first time, even though I had done all the puzzles in this starter area. Oh, or maybe I hadn't. Because I've done all of these, but it might be counting not the area, but all puzzles of this nature. And I just finished the last one over on the left, and now this is lit up. I'm not sure. Anyway, so this is clearly counting the lasers or signal fires or whatever that I've gotten. This is the orchard area, right? The counting which branch of the tree is longer. That's what this pattern means. And this is the areas where it like has black and white cubes to mark the answer for you. There's 3 dots. There's a lot I haven't done, I guess. I don't even recognize this one. And this is also a tree, which I thought was... Huh. Oh, I got stuck on this one, huh? What was I doing here? Right. And what is this unlocking? Wait, these are unlocked already. I mean, it looks like it's opening eventually the path through here. had like some... I made some progress on this, didn't I? This has two neighbors that are the same as it. This has one neighbor that's the same as it. That seems like the best starting point, but I couldn't make it quite work, as I recall. Because if this is on, whatever shape this is, it can always have one thing down here that's the same as it, and one up here that's different. Actually, maybe that is an interesting point. These two, I think, have to be different from each other. Is that true? No, it's not. They could both be off. No, because then this guy would be upset. But they could both be on. In which case, this guy would also have to be on, right? But they can't both be off. That's the one thing I can say about these, I think. Well, and that's just obvious from looking at this. Well, this is interesting, right? These two can't both be off for the same reason. They're next to one of these. So one of them is on. That means this can't be on because it would be part of too big a group. So it's off. And that means these both have to be on. Okay, good. That's something we can say with certainty, which is better than I think I had last time I was here. So these could all be off to satisfy this, or this could be on and one of these could be on. What about this 2? If it were off, we'd be pretty constrained, wouldn't we? We'd have to do all of this to stop the group from getting too big. And then this 3 couldn't connect up. It would turn into a 4. So I think that's not possible. I think this 2 actually has to be on. Which means one of these 2 is on, but I don't know which. How about this 3? If it were off, this would have to be on, that would have to be off, right? Is there some contradiction here? It doesn't look like it. Because we can't mark this on. The two would be too big, so we go like that. This has to be filled, and so that has to be filled, and we're done? Yeah. Oh no, a 5 by 5. Okay, at least this time there's nothing fixed in place. Wait, what? Isn't this impossible? Look at this middle. It needs everything next to it to be the same as itself, and now this 4 is in too big. Oh, no, right. You can add up groups. Okay. So again, we can assume without loss of generality that these are all on, or that they're all off. I'm going to make them off because seeing the purple dots on the blue background is pretty tough. And it's nice to remember there's a 4. So we know this group has to connect up to this 4, so that's off. We've already got size 6, and we need it to be size 8. And it takes 2 more cells to fill up, so everything else adjacent to this has to be on. And then isn't there going to be some ambiguity here? I can take this and either one of these two. Okay. This has to be on and an off neighbor. This probably doesn't matter. Oh, maybe there won't be ambiguity because of how the 6 has to fill out? We'll see. No, the 6 goes this way. Okay. So I think I can just fill in either of these two, right? Oh, did I get this wrong? Oh, it needs 3 like neighbors. Okay, sure. Yeah, those are both correct. This one I feel like was easier than this, because there's something so obviously impossible in the middle that I didn't see as obvious a starting point here. Well, last time I was here, I don't think I knew what the diamonds meant. Now I do. So those two have to connect to each other somehow. And so do these two. There's only 2 possible configurations. One would be this, and the other would be this, where the other direction is the opposite, of course. I don't think we can say that those are equivalent because of the markings in the corners breaking the symmetry. Suppose we did this. That might or might not be part of this group. Like, we can do that and it looks sort of fine, right? In fact, isn't this just an answer? Yeah. Is there gonna be... There must be something breaking the symmetry here, but... No, I don't know. So... There's going to be so many legal answers to this problem, aren't there? Because all 4 of the corners could be on or off and nobody would care. Isn't that true? Because we know that this square and this square have to be different from each other in order for the corner to be satisfied. Whether it's on or off, it needs exactly one neighbor the same as it. And in that case, turning this on or off not only doesn't affect whether this is correct, it doesn't affect whether anything else is correct because it's not connecting up to anything. So I think there's going to be at least 16 legal solutions to this. You know, how could you go wrong? Just guess something. 16 right answers. So, like, we know these are different from each other, we know these are different from each other, and these, so, like, obviously this would be the worst possible solution. But I don't see any way to make progress besides just, like, guessing this, and it doesn't really get me anywhere, right? To do that? I guess something we could try is see whether it's necessarily symmetrical. Like, suppose we did all of this and said each one of them has a blank clockwise of it and a thing counterclockwise of it. Suppose we did all of this. Does this just, like... I guess it's right. Just assume symmetry and see whether it holds. In some ways that is just bifurcation, but at least it's bifurcating on something plausible. So these guys... It sort of seems like something like that should be right. But I don't have any evidence. I mean, I guess it is right though, right? This is sort of interesting. The way these are like this one, for example, suppose it were on, then all of its neighbors would be off, and this would also have to be on, and all of its neighbors would be off. So, and the same would be true vice versa. So we can say that these two squares are the same as each other, and all of the things I've highlighted are the opposite of that. Now, we can do this all, like, this is another without loss of generality thing. I could flip things, but it would be equivalent. So now we can see these two have to be separated, or this has to be separated from these two. This has to connect up. Up here, I can't see any reason to connect these areas. It only constrains me, so let's fill them in. And since this is off, all of its neighbors must be on. And it's off because it has an on neighbor. So these have to... Oh, and we're just done? No. Oh yeah, we have to connect these up. I can't see them because it's cyan on gray. This has to be the same as all its neighbors. Let's assume they're on. Then this has to be the same as this in order to get out at all. Wait, what? There's 7 diamonds. There can't be 2 in each region. I guess this is counting as a diamond somehow? That's messed up. They didn't teach me that in the area about these things, did they? I guess maybe this is where they're introducing how the two mechanics interact. Not sure I like that idea. I know the Witness had a similar kind of thing where clues could be in different colors, and most of the time the colors didn't matter. But when you saw a clue that was about color, it saw other clues of the same color that were about other things. So here... I mean, let's just assume these are all on, I guess. That gives us this. And then aren't we toast? Right, I've assumed that this square, I could have assumed this square was on, but we would reach a symmetrical position where this purple has no way to connect to that purple. So clearly there's something about these flower clues, adjacency clues, that solves what is obviously a problem. But I still don't really understand it. Like, it can't just be this, right? Yeah. Everyone's unhappy. So, like, I could do this and connect that up, but these two are going to be unhappy, right? I'm going to do it this way so I can still see the clues. Well, wait a minute. This doesn't have to connect with that. It could connect with this guy right here. And then, like, this one could connect with this guy. Right? Like that. Yeah, there was no problem. I jumped to kind of an obvious thing, but didn't verify whether it was true. Oh my god, it's a 6x6. Alright, where can we start? We know that. That has to get out. This is all on. This has to get out. Now, this has to be off because this is connecting these two. These are off, which means their neighbors are on. This can't be allowed to connect up to over here. Oh, this is marked off, huh? So all of its neighbors are also off. This also has to be off, and it connects up to here. Oh, it's symmetrical. It's nicely symmetrical, isn't it? Okay, so that has to do that. So I guess this is getting to over here as the last thing for it to connect to, so it comes down this way. Which means we have to go up here to connect these two. No one cares what this is, apparently. This can't touch this group. So we get this. Now this has an on neighbor, so all of its neighbors are on. And we're done. Good. Assume without loss of generality this. We have to connect this up. Okay, I take it back. I'm going to assume the opposite. I hate... It makes it hard to see the clues when I mark them purple, or when I mark them gray, so I'm going to wait before I do that. Wait a minute. Who is this purple talking to? It has to be this, right? This has to somehow count as purple? That's interesting. Well, that, I guess, means these have to be on, like that, which means this whole area is on. Or off, I guess. Could we put these two in the same group? No, because there'd be no way... Oh, that's not true. I was going to say there'd be no way for this to connect to here, but in fact there would be. You could do this, right? And everyone's connected up. This being purple is a little weird to me, because it's not more purple than orange. All the examples we've seen so far have used fully orange as orange. Okay, this diagonal across the middle looks extremely powerful. Let's actually just assume this whole section's off. Now, we don't know what this is. It's on or off, right? However, we do know that its other neighbors have to be different. And the whole thing, since these are all twos, this continues. We can deduce at least this much without knowing what's in the middle. So, I guess... That's all that. And then there are just 4... diamonds that have to touch each other? Is that it? Do I just make sure... there's no connectivity between... Because, like, this could probably reach over here. And this could reach over here. We just have to make sure there's an air gap between them, right? Or, like, this could reach here. I think that's basically equivalent. So, yeah, in fact, it's perfectly symmetrical at the moment. So I can assume it goes this way and I'll never be proven wrong. So let's just do all that. And make sure there's a gap? No. Oh, what am I... Well, no, that's fine. So why are you unhappy? You're connected to each other in the same group. There's no other oranges connected to you. I don't know of any reason to treat these as orange. Last puzzle they were purple. Right? Oh, maybe they count as either one. So, well, no, because then I could count these as purple and it would be fine, right? I don't appreciate this. Like, I feel like this section is not introducing the rules very well. And it's not really in an area that is supposed to be introducing rules. It's supposed to be asking you to, like, combine two mechanics in an understood way. But it's just like, oh, by the way, here's this new rule. So if I'd wanted to here, for example... Oh... I was going to say I could have, like, done this to connect these up and they would still be in the same group. But of course that doesn't work because I break the constraints on these guys. Which of these little flowers am I supposed to interpret as being orange? It's clearly making these guys upset. I don't know. I could do that. Ah, wait. You're not happy with that, huh? You need to be off. And that makes these unhappy as well. But notice when I did this, these flowers became, these diamonds became happy. And when I do this, they're unhappy. So they clearly are seeing this as if it were orange. And if I do that, they're also seeing it as if it were orange. So they're not seeing it as purple. They're seeing it as like part of their own color. Okay, so let's start that over. And I guess we have the further constraint that these diamonds can't be in the same group as any of these flowers, I guess. So we knew that these two have to be the same, and therefore these two have to be like each other. So we got all of that. And this, I think, is obviously true. Now, actually, here's a thought. If I do this, is this guy going to be happy? It is. So we don't have to necessarily assume that the diamonds are connecting to other diamonds. They're finding other flowers to be friends with, right? Why is there no undo button, by the way? So that must be interesting, right? All of these flowers in the middle I can turn on or off at my leisure. But these ones in the corner I actually have already made a choice about, right? These need two next to them that are the same, so they both have to be off. And now I can say, oh, this is a finished group with the diamond and this thing. So if I were to wall both of these off, which I'm not sure yet I should do, but I could, none of them are unhappy. I probably should, because there's no use letting this escape to touch anything else, right? We want as little connectivity of these things as we can get. Now, what? Can I not just, like, do this? Yeah. Okay, so one that's even seems... One that's like a 2 and 2 seems to count as being part of either color group. Both color groups, even. Well, probably not both. All right, so here we can assume all of this. This orange can't be touching any of these, but that doesn't tell me yet. Wait a minute. Huh. Yeah, so they're making me understand what it means for a thing to be, like, split. I guess it is going to be part of both color groups, right? Because the only way for this to talk to anything that could possibly be interpreted as orange is to get it down here, right? And likewise, this purple, the only thing it could talk to would be here. So these two have to be the same, and so does this. This has to connect up. Like, this is the only possible solution aside from that. So this really does count as being a purple clue and an orange clue at the same time, if it's in a region that cares about colored diamonds. Okay. So these two must be different from each other. Because we need the... Or, no, that's not quite true. I could have all of this be on. Hello, I can't... Oh, no, right. These are highlighted. I couldn't have them be on. I need one of these oranges to touch an off flower, and one of them to touch an on flower, and likewise for the purples. So, in fact, we know that this orange and this purple have to be in the same group. And likewise for the other orange-purple pair. And they have to touch... They have to touch one of these. That seems really interesting. I guess you're going to have to go around like this or something, right? But that cuts you off, so go that way. Because you have to make sure you only touch one of this guy, or turn on one of this guy's neighbors. Or else the flower clue would be broken. So this looks fine, right? No, the blacks aren't connected. Sure. The blacks aren't connected. The blacks aren't connected. What the heck do you do about the blacks? That doesn't... Oh, I guess it's fine. Just... connect them like that and include the whites as well. Oh no, I accidentally got you! Two of the same thing. Oh no. Okay, can I do this then? That looks better, right? Yeah, so that unlocked this door. And then sent something down here, it looked like, right? Or no, this was turned on by having finished this one, I guess? Can't really see where the wires go, but I think it probably goes through there. Alright, well, I think that's plenty for today. Didn't give me any new signal flares, obviously. That's life. I'm stuck on a bush. Are there, like... There was a ton of stuff in this house. Did I understand any of it? Like, some, right? Huh. This seems to be teaching me how to interpret, like, paintings as filler for these? That's so weird. I see there's dark and white, but... Oh, and there's a 3 and a 2. How interesting. Huh. And a 2 and a 1. Wow. Alright, well maybe we'll give this area a shot tomorrow. 3s and diamonds. Oh, that's so cool. Anyway, I hope you guys enjoyed. Thanks for watching, and I'll see you next time.